Okay, let's get started. This is a session on how to build your own cloud encoder with FFmpeg. I'm Jan Ozer, and David Hassoun will be covering the cloud stuff. I'll be covering FFmpeg. A little bit about me. I'm a contributing editor to Streaming Media Magazine. My book project for this year has been Encoding by the Numbers, which is the first time I actually addressed FFmpeg. So a lot of the stuff you're going to be seeing is going to be in the book with a little bit more explanation. So don't think you have it all just because it's in the handout. The book will be more, better, all that. But and then I blog at streaminglearningcenter.com. David Hassoun, I met David 3 or 4 years ago on the presentation circuit. He's the guy I send everybody who asks for programming help, I send to David. He's the president and owner of Realize Consultancy, who does work for clients like Oracle, Adobe, Major League Baseball, and Lionsgate. So probably certainly the developer I trust the most. Again, I'm going to cover the FFmpeg side. David's going to cover the cloud programming side, and we have a lot of slides to get through, so if you can hold the questions till the end, that would be great. Okay, so who is this presentation for? You have lots of videos to transcode. We're going to be covering both single file encoding, of course, but as well as encoding to ABR, HLS, and Dash. We're not going to spend a lot of time explaining concepts like codec and packaging. And then on the later stage of the program, you're going to be familiar with creating command line executions in JavaScript. And then you have to understand some very basics of cloud servers and how to work with them. If you know all that stuff, if you meet these prerequisites, you should be able to leave here, fire up your own cloud encoder, and use FFmpeg to create files in the cloud. So you'll be getting enough information and enough code from David to make that happen. So it's pretty exciting. So here's my bit. The thing about FFmpeg is it's tremendously flexible. There are many, many ways to do almost every operation. I'm going to show you 1 or 2 ways. I'm not saying it's the only way. I'm saying it's the way that I found to be the best in the work that I did in the consulting side as well as the writing side. I'm going to show you the minimum commands. There's a lot more configuration options we're not going to cover, but you can, the command line scripts we'll be giving you will be sufficient to create files you can use. This is not a theoretical. This is stuff I've done for clients, stuff David's done for clients. Just so you know, the location of the configuration options within the string doesn't matter. You can put them pretty much anywhere. One thing about FFmpeg is if you don't choose a configuration option, FFmpeg uses the default, and we'll see what that means in a second. And then obviously, if you configure something in the command line, it's going to override the default. So here's the most basic FFmpeg operation. So we've got, this is a command line script. You'd run it in the cloud, run it, at the C prompt on your computer, run it on your Mac and terminal. And you call the program, that's FFmpeg, and obviously if it's located in a different directory, you need to send it to that directory. And then you list the input file. And this is just a Tears of Steel 1080p version MOV file. And then I call the video codec, which in this case is x.264, and then I name the output file. So if I have these 4 commands in a command line, I am going to encode a file that I can use and play and play on my computer. Not something you want to distribute. I mean, what we did with that command line is we made decisions for everything in purple, right? So we choose the video codec, and because we chose that video codec, FFmpeg decided, well, I'm going to use AAC audio. And then all the other parameters we see there are the default parameters for FFmpeg. So we can look at that and we can say, well, 15 megabits per second, probably can't use that if we're streaming. Keyframe interval 250, well, definitely can't use that. Scene change, that's another thing we got to work through. So pretty much what we're seeing here are all the configuration options we're going to be working through during the first 15 or 20 minutes when I'm talking. And then David's going to say, OK, now you know how to create these files. Here's how you do it in the cloud. OK, so bitrate control is very important. For the purposes of this next section, we're going to be looking at a file that's got pretty much extreme variability. There's 30 seconds of talking head, followed by 30 seconds of ballet. So low motion, high motion. And the question is, how do we encode this for maximum quality and deliverability? So the most basic data rate control for video is /b bitrate : v video And then here I'm using 5 megabits per second, so it's 5000K. And that's how you would set the bit rate in the command line. What we see in the bitrate viewer program to the right is we've got an average bit rate of about 5062 kilobits per second. We've got a peak bit rate of around 8.3 megabits per second. And then we've got extreme file variability within that file. So that's a view of each GOP in the file. And then the wavy blue line that you can barely see is the average data rate within that file. So if you were charged with distributing this file over the internet, you would say, holy cow, we may have a problem with this file because there's just too much variability. So let's see how we fix that. So this is 2-pass encoding, and we're going to look at 1-pass most of the time. I wanted to bring 2-pass in for bitrate control because that's pretty much the only way you can do it. So let's go through what we're seeing. The top line is pass 1. The bottom line is pass 2. Anytime when we've got the descriptions of the options in the sections on the bottom. So line 1, anytime you see a -y, you're going to overwrite the existing file. So if you put that in front of any command line in FFmpeg, if there's a file there in that name, you're going to overwrite that. And that's very useful for the first pass because really what you're doing with the first pass is you're creating a null log file. Every time you run a first pass, you're going to create that log file. Unless you use a different name, FFmpeg would interrupt you and say, hey, do you want to overwrite this file? So you put the -y in so FFmpeg knows to overwrite the file. And then you list, we see the input file, we see the video codec, we see the data rate, and then we see -pass1. That tells FFmpeg it's pass 1. You have to list the format in the first line. So we're saying, hey, this is going to be an MP4 encode, and create the null file. And the null file is the log file. And then the 2 ampersands and the slash basically say, hey, if this works, go on to line 2. If you don't have the ampersands and the slash, you don't go on to line 2. And then pass 2 is the second line. And the only thing really different here in this particular case is that we're saying, output the MP4 file, and then we name the file. So here's our 2-pass encode on the left. We've got a little bit better bitrate control. We went from 562 to 5007, but we actually have even a higher peak. So this is a tool called Bitrate Viewer. I'm sure it's hard to see here. You can see it much better in the handouts you can download. But on the upper right, you see the average bit rate. On the right, it says 5062. And then you also see the peak bit rate. And on the right, it says 8273. On the left, it says 8542. So the peak actually went up using 2-pass. Again, we have a file that is not easily deliverable. So what do? We go to 2-pass encoding, and this is the CBR option. And to implement CBR with X.264, you only have to list the target bit rate -B:\V 5 megabits per second in the first line. And in the second line, you tell FFmpeg, look, make the maximum rate, the top bit rate, 5 megabits per second. So you have the same target, the B:\V in the second line with max rate, 5 megabits per second, and buffer size, 5 megabits per second. And that's the video verifier buffer. You want to set that at around 1 second data rate to limit the variability in the file. So let's see what that looks like. So on the left, we see the CBR file, and all of a sudden we see a file that we can deliver this file. We can deliver this file pretty reliably. So the data rate is 4960, so it's a little below 5 megabits per second. The peak is around 5.3 megabits per second. You never get a perfect flat line, but you get a file that's a whole lot more easy to deliver than you would with the 2-pass, which you see on the right. The problem with CBR is that you get transient quality issues. So sometimes if you invoke strict CBR, the encoder has a very difficult frame to encode, and it can't encode it correctly. So you have 1 or 2 frames that might look like this. And this is from an article on my website. You can see the bit.ly link below. So I don't recommend using CBR. I recommend using constrained VBR. And typically, I recommend 110% constrained VBR. And a lot of producers use 200% constrained VBR. And you see the the two different command lines get you to those two different results. So you use the same command line on top. Again, you're only inputting the -b v 5 megabit per second data rate command in the top line. And then the second line produces the CBR file, I'm sorry, the 200% constrained VBR file. And here we're setting the max rate at 10 megabits per second. So that tells FFmpeg, we want the target to be 5, we want the max to be 10, and then we're increasing the buffer size to give a little bit more stream variability in the 200% constrained file. So that's 200% constrained VBR. The bottom line says 110% constrained VBR. So here I'm using 5 as the target, 5.5 as the max rate, and a buffer size of 5, again, to limit stream variability. Stream variability helps or hurts deliverability. And then here's what the files look like. So the 200% constrained VBR looks like the other files that we started out with, where we have extreme variability. That's a file that's going to be hard to deliver. And that's the CBR file next to it. And then the 110% constrained VBR file, you're going to have slightly higher quality than the CBR file. You're going to avoid the transient quality issues. And you're going to have a lot more consistency in the stream that's going to make that a lot easier to deliver than the 200% constrained VBR file. Does that make sense? OK. OK, so now we've set the data rate. Let's look at keyframe interval. So if you do nothing, if you have none of these controls in the file, you get a keyframe interval of 250 frames, and then you get a minimum keyframe setting of 25 frames, and then a scene change threshold of 40, which makes it pretty sensitive to scene changes. And what that looks like in the file, and this is from a product called Telestream Switch. So the white lines are keyframes. The tall white lines are keyframes, and that's pretty much all we care about for this particular slide. And what we're seeing is that we have irregular keyframes. And we know that if we're delivering video via ABR, we can't have irregular keyframes. We need shorter keyframe intervals, and we need keyframes at specific intervals. So how do we achieve that with FFmpeg? We reduce the GOP size. So the control for setting the GOP size is -G, and that's 72. And obviously, if this was 30 frames per second video, we'd use 90. And then we set the minimum at 72. So we're telling FFmpeg, hey, we want one keyframe every 72 frames, and we want no keyframe intervals less than 72. And then just to make sure FFmpeg gets the message, we set scene change threshold to 0, which basically says we don't want any keyframes at scene changes. Okay, so I don't know. This is what I always do. You probably could leave off the scene change threshold at 0. You probably could leave that off, but I just pretty much always throw that in. So what do you lose with this approach? What you lose is keyframes at scene changes. So everybody thinks keyframes at scene changes increase quality, and it does to a certain degree. So how do you get keyframes at scene changes plus the regular keyframes at 72 frames? So we'll see that in a second. This is, if I use these commands, this is what I get. I get, again, in Telestream Switch, I get keyframes at every 72 frames, and that's what I want for regular stream switching within the ABR algorithms. Now, if I want keyframes at scene changes and a keyframe every 3 frames, I use the command string shown on the upper left. The force keyframes algorithm shown up there. The 3 is 3 seconds. And then once I use that, I'm saying I want a keyframe every 3 seconds. And then you don't need to include the next 2 commands because it's going to default to the default. So the default there would be a keyframe interval minimum of 25 and scene change threshold of 40. So you can put those in, you can not put those in. But what you end up with is you get a keyframe every 72 frames, but you also get keyframes at scene changes. So what's the quality difference if you implement keyframes at scene changes? In this particular 2 files that I compared, using PSNR, the scene change detection was a whopping 0.08% better. So that's not 8%, that's 0.08%. So I typically just use the 72-72-0 approach, but if you want to have forced keyframes, now you know how to do that. Okay, what about resolution? Two ways to do resolution. S for size, you can just input the resolution that you want, and that's typically what I do in most of the production stuff that I do. What do you do if you don't know the specific resolution of the file, but you want it to be a certain width or a certain height? You would use the command on the right, followed by, or after the VF, which tells FFmpeg that there's a video filter graph coming. So there what we're saying is we want to set the width, and then we want you to set the right height, computed by using the same aspect ratio and making sure it's a multiple of 2 just to make things easier on your encoder. Okay, so two approaches. If you know the resolution of your file coming in every time, I would use the one on the left. If you're dealing with different file sizes coming in, I would use the one on the right. Okay, what do you do to change the frame rate? -R is rate, and then just insert the frames per second. If you don't include a -R, it's just going to encode using the input. So if you don't want to change the frame rate, you don't need to worry about the -R command. It's just going to keep whatever the input frame rate was. Typically, you'll use this when you're encoding in an encoding ladder, and you've got the lower quality files that might be 480 by 270, and you may want to cut from 24 to 12 or 30 to 15. Okay, setting the profile and the level. These are important things for mobile sometimes, certainly for Android. If you don't input a profile, FFmpeg will encode using the high profile. So if you want the high profile, you don't need to set the profile. Level is a little bit hard to tell what the it's hard to tell what the default behavior is. If you need a specific level in the file metadata, you need to include that command up there, but you need to be aware that FFmpeg isn't going to limit the encode to that level. Meaning, if the level 4.2 is 1080p, and you insert a 4K file and don't manually change the resolution to 1080p, FFmpeg won't change it just because you put in level 4.2. So if you have to limit the level of your encode, you need to do that manually, and then put this in more for metadata purposes than for any kind of file control. Okay, X.264 has a number of tuning mechanisms. Tuning mechanisms trade off encoding quality against encoding time. Okay, so what we're looking at on the left is the presets. Presets range from very fast to placebo slow. And then we have tuning mechanisms on the right, and I'm not going to cover tuning mechanisms in this particular conversation. But the preset, if you don't include a preset in the command string, you're going to use the medium preset. And that, realistically, that's a pretty good default. And using the medium preset, in yellow, you see all the decisions you're making by using the medium preset. In green, you're seeing some of the options that we're going to manually change in this discussion because I think it's important to do so. So if you want to know exactly what you're doing with each preset, I kind of took some things out of this table from the URL on the bottom. If you want to see the complete list, you can go to that URL. So which preset should you use? What we're seeing here is the blue line is overall quality. So the absolute top quality is somewhere between very slow and placebo on the right, and then encoding time is in red. So what we're seeing is if you choose the very fast preset, or the faster preset, hard for me to tell at this angle. If you choose the faster preset, you've got 99.53% of the quality, and you're probably 30% of the encoding time from the medium preset. Okay, so anybody who's thinking, I just want to use the very slow preset to get the maximum quality, you're really getting very little additional quality, and you're really expanding your encoding time. So where does this become important? This becomes important, hey, if you're in the cloud, which is where you're going to be after this discussion, you're paying by the hour. So if you use the very slow preset, you're going to pay for a hell of a lot more hours than you would if you use the faster preset. And the quality difference will be indistinguishable. So if you're in a hurry, if you're up against capacity, if it's too expensive to encode using the medium preset, you can pretty much drop to the faster preset and not notice any quality difference. You probably could go even lower than that, but that's where you see the quality start to decline on the left-hand side. Okay, B-frames is another configuration option that I like to control. This is the effect of B-frame configuration on file quality, and these are some of the files that I'm working with in the book that I referenced. We see the PSNR score on the left. Higher scores are better. We see 0 B-frames on the extreme left and 15 B-frames on the extreme right. In some files, in this case, this is a tutorial file, which is a Camtasia-based file. We see that B-frames reduce quality. In most files, we see that B-frames really have almost no impact on quality. So a lot of people say you should use 15 B-frames. Looking at the tests that I've run, I don't see much difference. And B-frames can cause problems with quality if you use too high a value. So what I see here and what I typically recommend is a B-frame interval of 3 because that delivers most of the quality you can get, and there's no downside on reducing file quality at the higher levels. How do you set B-frame? You set B-frame with BF, and then you set the B-frame interval. And then the B-frame strategy is pretty important. And this is basically telling the encoder how to choose which frame is going to be B-frame and which frame is going to be a P-frame, or even, I guess, a keyframe as well. And the two options, 0 is not recommended if you look at the docs. Number 1 is fast, that's the default. Number 2 is the slowest, but it's also more accurate. So this is Telestream switch again. And what's fun about this tool is it actually tells you in the upper right what percentage of the frames are B-frames. So if you use a strategy of 1, 9% of the B-frames, or 9% of the frames overall are B-frames. If you use a strategy of 2, 58% of the files, or 58% of the frames are B-frames. So if you think B-frames are important, then you need to use a strategy of 2. If you don't think they're important, then you can just use 1. It's going to be faster. The quality difference, again, you just don't see a lot of difference between quality looking at B-frames. But the quality of the file on the bottom, this got me pretty excited. I was like, wow, B-frames are so efficient. This, the second approach is going to be much higher quality. And then you run the numbers, and it's like, well, yeah, B-frames just don't add as much quality as everybody seems to think they do. What about reference frames? Reference frames are another way to save time on your encode. So, what are reference frames? Reference frames are frames from which the frame being encoded can find references. So if you have more reference frames, maybe you find more references. More references mean more efficient encoding. Okay, so more references are good, right? Well, what we're seeing in the blue line there is the qualitative difference between 1 reference frame and 16 reference frames. So we're seeing very, very, very little quality difference between the alternatives. On the other hand, the encoding time in red goes from very, very low to very, very high. So this is another area where if you're capacity constrained or if you're worried about costs in the cloud, you can really cut encoding costs by just using a reference frame of 5, which is what I recommend, or even going down to 1. So reference frames don't add a lot of value quality-wise, but they do add a lot of time to your encoding. How do you set audio? These are pretty straightforward commands here. -C for codec, :A for audio. AAC is the audio codec you want to call. What bit rate? 64. How many channels? 1 or 2. And then what's the sample rate? AR. If you want to use AAC HE or HE2, you've got to call a different codec. You can't. There's no way to use the AAC codec and turn those to HE or HE2. Okay, so when you produce ABR videos, you encode multiple times. Now, you can run the first pass once, and first pass takes, it takes a while. So if you run the first pass once and then encode all the other files from that pass, you can save time, right? Because you're losing the first pass for every file you're encoding other than the first one. The question is, which configuration options do you put in the first pass? So here's an example where we're producing 3 files in our adaptive group. One's 1080p, one's 720p, and one's 360p. Okay, and what we're seeing here is pass 1, I'm using the 1080p config, which means there's no size change. And you see all the controls that we, or all the commands that we've talked about. And then in pass 2, I'm going to move. In pass 2, we're creating the 1080p file here, we're creating the 720p file here, and we're creating the 360p file here. Okay, so what are the differences? The differences are going to be data rate, but most notably, we have a change in size and a change in size. So the question is, which configuration do you use in the first pass? Do you use the configuration from 1080p? Do you use the configuration from 720p? Or the configuration from 360p? So what I did here was, these are the PSNR results from the slide we saw previously, where the first pass was the 1080p. These are the results from 720p was in the first pass, and this is the results from 360p in the first pass. And we see in the delta column, there's not a huge amount of difference in terms of overall quality. I got the best results overall using the 360p first pass, which makes absolutely no sense, but you know, that's what I got. So a lot of people, if you read the literature, what people recommend is they say don't use the file on either extreme. Use one of the files in the middle in the first pass. And then I just ran the test. This is what I found. It wasn't, 720p was very, very close. So the common wisdom seems to produce a good result as well. It doesn't look like you want to use the 1080p file, your highest quality file, as the first pass. Everybody get the point I'm making here? You got to choose a configuration to use in your first pass. Which should it be? What I'm seeing here is that it shouldn't be the top quality one. I have no idea why, but that's what my test showed.
Is there any variations in code time or size of the file?
Any variations in code time? Good question. I didn't monitor that. I'm guessing there would be, but I don't know how much. Okay, we want to send our file to HLS players. This is how you do it. And basically what you're doing is your dash format or dash F, that tells FFmpeg, create an HLS files. Again, there's probably 60 HLS commands depending on what you're doing, captioning, DRM, all that stuff. But if you just use these 3, you're setting your segment length. Obviously, you want that to be a multiple of your keyframe interval. You're setting the maximum segments in playlists. David could tell you why that's important. I can't. And then in the HLS flags, you have the ability to say, OK, I want one file, one long .ts file with byte range requests or individual TS files. OK, so traditionally, HLS has separated all the files into fragments. And then you shipped all those fragments up to all your CDN and all the caches everywhere. And that was kind of a mess. You can also use a single file with byte range requests after HLS version 4.0. So this is how you do it if you want to implement the single file. So what does Apple recommend you do? This was actually kind of interesting because Apple changed this in August, and I wasn't aware of it until I was getting prepared for this show. And what Apple tells you with the updated TN2224 is they're saying you can assume that every iOS device you're sending video to is compatible with HLS4, which means you can use one file with byte range requests as compared to single or individual .ts files. And you should also assume that it can play the high profile, which means you don't have to use baseline main profile for the low quality iterations. Now, it doesn't mean you have to do it that way. I probably would not do it that way for the next few months. But Apple's recommendations are now high profile and the ability to use byte range requests rather than individual .ts files. And no extra charge. Here's the HLS command string for the first 3 files in TN2224. So if I was creating the first 3 files here from the bottom from the bottom up, this is what the command string would look like. And then you probably would change this to somewhere in the middle, but these are all the controls you need to use to create. In this case, I'm creating one file, and then I'm also going to create the M3U8, the manifest file for that file. Now, the one thing FFmpeg does not do is create the master manifest file, and David's going to tell you how you need to gather that information and present that as well. And then for Dash, the most popular tool is MP4Box. It's not a tool that I've used. You could do the encodes with FFmpeg, get it to the MP4 files, and then use MP4Box to produce the segmented files or the byte range requests as well as the manifest files. But I don't think you can do that in FFmpeg. So
all right, so now it's my turn. So a couple quick questions. How many people here would consider themselves software developers or engineers of some sort? Hey, you guys like code? Cool. All right, so I have a couple cool things to show you, and we're going to talk a little bit about some high level as well, so you guys can kind of get started and do a bunch more, hopefully. So great. Now, Jan did an awesome presentation on everything you need to know. Yeah, just hold it for later. Don't worry, there'll be plenty of time for claps. On everything you need to know about FFmpeg. Really key stuff about settings, understanding 2-pass, 1-pass, benefits, time, so forth. Now, the goal of all this is that we want to be able to do this at a much larger scale, right? We want to be able to take this to the cloud. And what do the considerations we have to do there mean, and what are we going to get out of it, and so forth. So, there's always going to be the question of, okay, well, there's different clouds. Some of them work a little bit different, a lot of them work the same. Was everyone there for the keynote today? Jeff Tapper, cool guy, yeah. So one of the things he said was really important was cloud native, develop for the cloud. And I agree with that, and I disagree with that. Part of the challenge can be is if you marry yourself to one cloud, what happens if the client then, or your whatever reasons you have, cost benefit also to change. So that's something to keep in mind. I agree that you should always be thinking about cloud first, but in our organization, we've also really tried to be cloud agnostic. That doesn't mean we won't leverage the tools provided by any of these clouds, AWS, Azure, doesn't matter. And they can have amazing tools, especially when it comes to things like scaling, right? You don't want to always you don't want to create that for yourself per se. On the flip side, if you did, you might be able to carry it with you. But in how you develop your actual applications, microservices and all that, that really becomes key that you do create this stuff, and you want this to be agnostic. You can take this anywhere you go. So we're not going to go deep into, well, how do you scale on AWS? Because it can be different on Azure. No, there's that. We're going to talk a little about those high levels. But no matter what, you should always try to think a little bit upfront what cloud you're going to use. There's also the point of, well, we also might want a hybrid. Maybe we want some parts on the cloud, some parts aren't. We actually created a demo that I'm going to show you guys that can run easily on the cloud, but I'm going to run it here today, but it's going to push everything to S3 in the end, because that's one of the key things that we're also going to talk about, is things like transfer, right? And how is this stuff going to play out when we go to a cloud environment? So as we continue on, you need to think about what do you really want to get out of this, and where are you trying to go with it? What type of bit rates? How much content will we be working? Cloud is all about kind of pay as you go in sorts, right? You're going to be paying for things like transfer and for instances and usage. So thinking about what you're going to do and what you're going to be doing, and how often and the volume become critical in making that right decision, A, to go to cloud, and the concept of buy versus build. When we're talking about what we're doing now, it's going to be build, not buy. But we got to pay for the pieces and parts. You want to make sure you're not going to end up upside down in that situation. So thinking about what type of files are we using, how many of them, what is their file size, what are the renditions we want up front, are all really important things that you bring to the table to work out. And also, one of the big things that you can do, even with FFmpeg, that's not really offered in a lot of the services out there right now, is live. You can work with live ingest of feeds and convert those on the fly for packaging and be able to get those out quicker for other things too. There is a lot of complexity with that. I can talk to you about some projects that we've had to do with it. Lost a little hair, but we were able to get through it. And there's some really cool capabilities built right into FFmpeg. Then the enhancing that with the capability of the clouds really offer some pretty exciting things. Things also along lines of using this in the cloud for packaging. Doesn't have to always be for encoding too. These have great values and different routes that you can do, and we can talk about that and also answer some questions, but we want to go a little bit further. A big thing that one of the reasons why we've done a lot for our customers isn't just because, hey, we just want to encode that file. They want a lot of other things with it, and you can do a lot of that starting with FFmpeg. Things like sprite sheets, right? So we can have enhanced control bars with nice skimming, or other elements that we want to pull out the video. Different frames at different intervals, at different sizes for different creative purposes, as well as all the data stuff that needs to go with that. Like we talked about, encoding doesn't, right from FFmpeg, won't create that set level manifest for us. So there's other pieces that have to be wrapped into that. And that's one of the biggest benefits if you do create your own cloud-based services, that now you can have that tight integration with your other services that you might need, as well as the other capabilities. And then there's great tools and libraries out there. So dive into a little bit of our experience. In the last couple years, we've done a boatload of projects when it came to cloud encoding in different routes. A lot of it's all about workflow. We've done some really cool stuff with like law enforcement and body camera, where we have a massive amount of video coming into us, and what do we need to be able to do with that? And we're going to talk a little about how some of this stuff applies as we go. A little bit of things that we've learned and done. We've done some scale testing and so forth, and we found, like, for instance, on Amazon, the M3 Large is a really good bang for the buck when it came to what we're able to do with our encoding. We're going to talk a little bit later on also about GPU and how that can play in, but to give you a direction to at least look at a starting point, those are a pretty good instance type. They give you pretty good CPU and a really pretty decent return for the cost, and we've used those quite a bit. On Azure, we did the DS2 V2s, which is just good to know. We generally also always will use Linux, mostly Red Hat, because we get more squeeze juice ratio on performance and cost with that. So they're going to have a little bit less overhead with not having Windows on there, and we can take advantage of that a little bit more. I'm not going to run you through, like, hey, how do I set up my first cloud instance? But here's pointers in here. Also, as Jen mentioned, the slides are available on the streaminglearningcenter.com, and there's also additional notes within there that kind of walk you through some of that. But here's the pointers to get you guys started on some of that. As I mentioned, when we're talking about video, if you try to run FFmpeg on your nice Mac laptop or Windows laptop, it actually can run pretty fast, and by default, you'll get pretty good performance. A lot of times, though, it will be using GPU automatically on your devices. You run that on this same nice EC2 instance, things seem slower. Actually, they can be a lot slower at times. And that's going to be part of the GPU factor. GPU has an amazing benefit when we're talking about video encoding. FFmpeg does have GPU support, but just know when you start trying to run this on Linux and servers, it will be a rather large headache. The bigger issue is actually going to be the instances. Most instances, unless you get specific ones that have GPU support, will not give you that benefit. And they are very pricey in comparison to the others. We've done some comparison stuff, and we found that we actually were getting a little bit better on our throughput using multiple M3 Larges than the cost of the GPU instances. It can depend on the type of content, the volume of content, what you're trying to get out of it, and how you're going about it, single pass, two pass, all that. But those are factors you have to do. We gave you a little bit of pointers on some stuff here. You guys can hit us up as well with it, and we can give you a little bit from what we did. I don't want to go too much on it, but know that's an option. But the challenge is right now on the cloud side, the instances are still rather pricey on the GPU end. So when you actually want to go and start doing some of this on the cloud, the key thing is you have to get an instance first, and I give you the slides for that, and then you have to start getting your software on there. At the very least, you need FFmpeg. We use ImageMagick a lot. That's used for things like sprite sheets, thumbnails, and image manipulation. And then it just depends on what your technology stack is going to be on there. Ultimately, you're going to probably want, instead of just a piece of hardware that you can go run command lines all the time, some kind of application tier, right? Java, Scala, .NET, your call. We've done a few projects now using Node.js because it's quick, it's easy, and the negatives of normal Node.js stuff, it's single-threaded and so forth. They kind of balance out a little bit for us on some of the projects that we've had that just made sense, because all the heavy lifting, all the actual encoding and so forth isn't actually done by Node. We don't have that same thread limitation and performance implications. We're just using this simply to give us an API and to control key aspects, queuing mostly, right? So I can say, hey, encode, 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 and they stack up appropriately. So we put together a really cool sample for you guys that we're sharing the code and all that. It's written in Node, and you can see how this works. Also, you're generally going to want some kind of database for persistence. You don't ever want to lose everything that you did or know where you need to pick up again, especially if you're talking about, hey, we're going to be throwing massive queue, could be thousands of files in this queue, and oh crap, the server went down. Where was I? Which one do I got to do again? I don't want to do them all again. Having something that gives you persistence so you know where to resume, know where your status is, have log management becomes really important. Once again, pick your DB. We've used Mongo a lot lately, and that is whatever you want. And then also SDKs from your cloud provider. AWS has excellent SDKs, and the other ones have pretty decent ones too as well. And they're for whatever, generally they have them in almost all the main languages. As a quick kind of tip for you guys who haven't done much stuff on the command line or on the servers, once you kind of log into your server and your SSH, here's an example of how you can pull directly down some of the libraries. So for instance, here's FFmpeg. You can go figure out which static build you wanted to get. You can log into your server. You can actually pull down with the wget the tar file and be able to extract it right there and then start running it right on the server. Hopefully this is just kind of some nice tips and pointers or stuff that you already know. So as we kind of move forward, some things you really need to consider. Aside from just your command now, you need to start actually working about what your system's going to do and how's it going to work. Things that you have to bring into consideration is multiple queues, right? I have a lot of files. It's not just going to be one at a time. Or maybe it is just one at a time, and that's fine. What do I need to do aside from just the encoding? Well, I'm maybe going to HLS. I need to create a set level manifest. I want thumbnails. I want sprite sheets. What else there? I need to work with closed captions. All these things need to come into consideration. Now, a good idea is to consider how you want to put that workflow together. We've done stuff in a couple different ways, but a lot of it's been real similar to how AWS Simple Workflow Service works. And if you guys have worked with that before, it's pretty cool. It's kind of neat. But it breaks things down into a few different concepts. You have workflow, which is your whole end-to-end kind of execution. You have your steps within that workflow, so ingestion, processing, transfer. And you have individual tasks, creating alternate bitrate renditions, thumbnails. And then there's also things like adapters. We've done this so we can be a bit more agnostic. So we can have a AWS S3 adapter or an Azure Blob adapter on-prem. So we do that for things like storage and file management. Key things that you also need to do that you really need to consider about is file transfer. We're talking about videos here. Videos are not small. They can be. They can just be a few megs, and that's great. You're lucky if it is. We're talking about gigs oftentimes, large video files that need to go up and need to be transferred and need to be done effectively. By default, you need to be careful on how you're doing that type of stuff. Also, are you doing it through a web interface? Are you using enhanced tools like Aspera? But if, say, we're doing this through a base web interface, a key thing you need to try to make sure you're doing is you're doing things like multi-part upload. Hopefully you guys are familiar with that. It's really important. The idea is that it can do chunks of the file and put them back up together on the far end. That really makes a huge difference for the performance of transfer, both to your EC2 instance and from your EC2 instance to your storage. So normally you're going to have your instance that does your encoding, your processing, and you're going to push it to your storage. Or you're going to pull it down and then use it after the fact. The AWS libraries has that built in. Really, really good. Very valuable and incredibly important to do. Azure Streaming is going to be put as a block blob as the alternative there. Also, one of the challenges that we've seen a lot of times that come up is like, great, we came up with this new encoding solution. We want to start using it. It's cloud. We built it. But holy cow, we got a backlog of, 50 terabytes of data that we need to go. But once we're past that, like the day-to-day is going to be fine. We'll be good. How are we going to deal with this initial flow of data? I don't have the bandwidth or the locations to do with that. There are cool tools out there that are going to be cloud specific for that. There's something called Snowball from AWS. That's a really cool little device that they'll give you and allows you to have like expedited transfer and other stuff to get things on there. In Azure, there's some other stuff that you can look at too. Oftentimes, if you talk to the cloud provider, you talk with who you work with, they have alternatives. So don't think you're going to have to do that. I remember years ago, we did a massive encoding project. We had everyone in our office taking hard drives home to use their home, DSL and Comcast connection just to get content uploaded in the very beginning. And it took us weeks. Now that's not so much the case. You can ship drives. You can do other things that can help with that. So don't overlook your initial hurdle. And then key thing that really majority of your time that we've found is managing your queue. Processing takes time. This is not a instantaneous result. You can speed things up. You can get excellent quality, but encoding is not super fast, especially when we're not talking about a pure hardware solution. Even then, we're hoping for things like real time or slightly faster. So thinking about how to manage that so you have a service that can work well is going to be really important. So queuing, keeping that persistent, and really taking considerations around that becomes a big part of the work generally you're going to be building at the application level. The cool thing is there's lots of tools out there. When we look at just things from like the Node side, these are some of the libraries that we use for some of the projects that we've had in the more recent time. You know, AWS has an amazing SDK for FFmpeg. I don't know if you guys have seen it, but there's a project called Fluent FFmpeg. It allows you to work with FFmpeg in a more standard kind of scripting approach, and then you can say, okay, execute that. And then it compiles all the parameters that you were able to work with and runs the FFmpeg command from a node. So that's pretty handy. It makes working with FFmpeg a little bit more readable versus -F and all sorts of good stuff. But you can still see that and you still work with it. And you can also just execute a command. So once you fine-tuned it, or if you want to take one of Jan's lovely ones after you buy his new book, then you can also go from there. So here's a snippet showing a little bit of that. And I'm going to actually kind of walk you guys through this demo that we put together. But here you can see we can bring in input options, specify things like the output options. Specifically, we're setting the HLS time. That's going to be our fragment size, our list size, and so forth. Put that all together, and then in the end, we can just say, hey, go ahead and execute FFmpeg with our input and our output, and go from there. So I'm going to show you guys a little bit of a sample that we put together for you guys. It's now public up on GitHub. The links also, as you saw here in the slides, which you can also get from the Streaming Learning Center. I'm going to start this little server. Yeah. On it. Yeah. Woo. Maybe not that big. All right, so I have this now running. There it is. This is the front end for this. So one of the key things you start building a cloud solution is generally the number one thing is you need an API. Now, API can be so it runs headless, doesn't have a UI over here. You can build it into your other tools, or you can also build out a web app to help with that, integrate with that API. So here's a little front end that's being served up right from our little node server as well that we have running, and allows you to start working to encode. This thing runs just fine on any of the cloud services. And we have a few things set up. You can specify your frames per second. You can specify your bit rates, your fragment size, and you can work on what file you want to encode. Now, by default, it has this thing called output type default. That means it's actually going to give you all multiple bit rates. So it'll do a multi-bit rate ABR. It'll do all of them 8 seconds and 2997. You can also change that and say, hey, I want to do just HLS or MP4. Default does HLS, so it actually does it all out for the fragments and so forth. I'm going to leave that, and we'll see this actually run and execute and drop files here, as well as upload this to S3. So I'm going to hit Browse. I'm going to select. This is a old animation from my college days. And I'll hit Submit. Now what's going to happen is it's going to transfer this over to my instance. In this case, it's actually running local. I wasn't too sure about the internet, so I wanted to be careful. Run encode, give us progress that's encoding it. Then it will do a multi-part upload to S3. It also is going to generate a set level manifest for us and provide all the URLs back to us. We actually even built in the ability to show signed URLs, so you can see how to work with signed URLs when you're working with clouds. One of the key things when we started working about cloud encoding, security. This isn't meant for everyone. I need to start protecting things. So there we go. You can see here, this is the actual call that it made to my API. And if I look at what the call actually looked like, I specify all the information that I want to do, the frame rate, the fragment size, so forth, to this API, and start transferring it. Over here, it gave us the update. It said it was encoding. Transfer was almost instantaneous. And then it was done. Now, these are actually all S3 URLs. This actually took this file, encoded it, and uploaded it to S3 for us. You can see here, locally, this is where it stores it on this. And there's actually the ability to say automatically clean up once it's done transferring, and it goes from there. I can now see if this actually works. I'm going to take this file. I have a little manifest tester app that we built. Tell it to show video. And here it loads the top set level manifest. There's the video, and it's able to play. So this is, using a cloud-based encode with FFmpeg, and I'm going to show you guys some of that commands and so forth. Then also going through a whole workflow from ingest, transcode, manifest generation, push to S3, and providing a web feedback form for that. And we take a look at our set level or our stream level manifests. You can see here we have our different fragment size, everything's set, had the 8-second fragment. And we can do different things. We can say, hey, I don't want HLS, I just want MP4. I can go get a different file, and I just want the 1 megabit per second. I can hit submit again. If multiple things are submitted at the same time, it's just going to queue them up. All the heavy lifting done by FFmpeg, and we'll leverage the system to the fullest that it can. So if I come back over, everything's also being logged out over here. I'll show you guys a little bit of what's going on inside this code. Here we have an encoder.js file. This is where it's actually going to go through, create our input and our output options based off of what was sent to us in the API. Here's where you can tune these FFmpeg commands to really get the better quality that you want. When it's all done, it's going to call execute FFmpeg, where it actually uses the FFmpeg library, the Fluent one, puts that together, sets it up so we have feedback on our start, our progress, our end, and our errors, so we can feed that down to users, and then tell it to output and run. Once it's done, we actually have to create manifests manually. Right? There is not an easy way to do that with FFmpeg. So once again, at your application tier, that's going to be a key requirement. In this case, we're saying create manifest after we've gotten it successfully created from our encodes. And then we put together information based off of the parameters that were sent to us and that we wanted to use in our encoding and write a file. So in the end, we do a file system write file after we've constructed the string of the multi-bit rate ABR manifest that we want. We have a separate class that's handling the file system and one that's also working with the uploader. So we can do a multi-part upload to AWS. So it works out pretty well, and it's pretty handy. All this is done in through a queue. Any new files that comes in while it's working, it's going to wait till it's done, and it'll pick up the queue. So we put together, hopefully you guys find this handy. Obviously, we don't have time to go through all of this, but you guys now have it, and you'll have our contact information as well. But this is an example of how you can start working with a cloud-based encoder pretty quickly, and a good building block to help you get started. So if we come back over now, things that are not obviously done already is scaling. How can we grow? FFmpeg will not error when the CPU is busy. It just takes longer to process. Keep that in mind. If you try to encode 50 jobs at the same time, well, maybe at that point you might actually get an error, depending on how many CPU cores you have. Things are just going to take slower. All of them are going to take slower. So sometimes it becomes really important to find that magic line between how much concurrent and how much queue I want. I want to have 5 jobs that can run concurrently, and the rest are going to go in line, right? Finding that balance becomes really key and is dependent upon the system that you're going to be using and the hardware specifically. And things that take into account with that are going to be volume of the files you need, the average size of the files, the processing time, what's going to be acceptable, and so forth. The only way you're really going to get these answers is when you start benchmarking it and see. I can tell you a little bit about things that we've learned, but it really varies so much on the content at that point and what your use case is. A lot of the stuff we have, it's been fast is the most important. It doesn't matter that we could get better quality with a dual pass. We just need to be able to get it out, because a lot of times these are just proxy files. Think about like body cameras and police footage. In their content management systems, it could just be as simple as we need to have that video and be able to review it no matter what, we have the mezzanine file. We can never lose the mezzanine file because that's evidentiary. So we need preview files that are lower bit rate, but we need those as quick as possible because the truth of the matter is we're going to have thousands of videos coming in all the time as shift changes or so forth. Your use case really defines this, and that's the benefit of building, is that you can really build around your use case. So things to consider to handle scale, you can get bigger instances. Bigger instances going to be handle more concurrency. Cons can be more costly. More instances, cheaper, can be scaled up and down only to pay when needed, but more complicated to manage. That's when native cloud really comes into play. Use the tools that the cloud providers have to help you with your scaling, and that's what's good. An important thing is that your client, your individual nodes, when you create this little server application that's going to run in the cloud, make sure it's standalone. You can have a centralized data service or like database more so for your retention, but everything should be standalone. That way you can scale it. I can now have 10 nodes running simultaneously. I can have 20. We're not talking about grid encoding where we have, hey, this encoder doesn't do a quarter of it, this encoder doesn't do a quarter of it, this encoder doesn't do a quarter of it. That's not what really works as well in the cloud-based encode system. As I kind of touched on this a little bit, really think about what you need to use for auto scaling features. Automate the spin up and down of instances based off of criteria. It can be done on instance load, periodic need for faster processing, time of day, specific events, so forth. Great things out there to help with that. Last but not least, who here's worked with Docker instances? If you haven't, look into it. Who here knows about virtual machines? Okay, see, even more. Docker is kind of Docker instances are a way that now I think a lot of virtual machines are moving towards, and it's a better distribution of resources within an instance in many ways. Now everything that we do largely has to work with Docker instances, and the key things with that and with anything that comes to scaling, whatever you build, it has to start up fast and be able to work quickly. Otherwise, your scale comes in a problem. Also, great points that Jeff Tapper brought up. So hopefully, you guys got a boatload of information in about 55 minutes or so, and some good stuff to walk away with. You have some great settings to actually go out there and apply from the FFmpeg standpoint. You understand, hopefully now, the real benefits of things like constrained bit rate, ABR, 2-pass, and how to work with those together within the FFmpeg world. And that you have at least a bit of information now on, great, here's some of the things I need to consider when I want to take this to cloud, a primer on where to start with some of that, and a demo to get you going. Any questions for either Jan or I?
So the elastic load balancing aspect of AWS.
Repeat the question.
Since you said FFmpeg doesn't error when there's a lot of load on a given VM or EC2 instance, what metric do you specify to say I want to start another instance?
So I think the question kind of is, when working with FFmpeg, how do you know when you need to scale, right? Well, the CPU monitoring can be good, but yes, the thing with FFmpeg is always going to use as much as it can, whether it's one file or more. That's where your application logic can definitely come into play, right? And also, or it can be sustained time of CPU. Hey, if the CPU is sustained longer than X amount, then that can be. The point is that you bring up a really good point that when you're working with encoding, you can't always use the traditional metrics for auto scaling. Of, oh, my CPU is at above 80%, I need more servers. You're going to be paying all the time for very little, right? So you have to have a little bit more logic within that, but you can still integrate with their services to help with it.
Yeah, what's your experience with maybe with CMAP, encoding files in the CMAP?
So the question relates to CMAF, which was, I guess, adapted by Apple in June.
So that's kind of the new standard that's emerging now.
No, I know what it is. How would that work its way into FFmpeg? Is that just, I guess some developer would add it, or?
Yeah, I haven't had it. I mean, for us, it hasn't come up yet for our existing customers, so we haven't dug too far into it. But I think you can definitely achieve it pretty well in a couple different.
I was wondering if you knew if it was already available in FFmpeg in different settings, or if there were.
June?
Yeah, I don't, but obviously FFmpeg downloads for it. So if you have developers on your team that have the ability to program against FFmpeg,
Hit me up. One of my guys, I think, actually has some information on that. And I think you can do some stuff with FFmpeg right now, but I think it also requires a little bit of custom afterwards. If you want to ping me, I'll be happy to follow up with you on that.
So do you use a bit of GPU for transcoding and packaging? And given the costs around that, have you found like an even tighter way to spin up and dial GPU-based?
So the question was, ultimately, how can you optimize the use of GPU instances? Is that correct? Yeah. We've had a lot of problem figuring out what the magic blend to get GPU to be both cost-effective and time-effective for us. In the test that we did, we ended up leaning more towards not using GPU. I think with like a lot of longer form content, it would make a bigger difference. But since the more recent stuff, we've been looking at sub 1 hour, more like 30 minutes. When we did testing and comparison, like it just wasn't worth the cost benefit that we saw. And having either more instances or beefier instances, it was fine. But that was also based off of the requirements for that specific customer. So I don't have a real good answer of like, hey, well, if you go with X, Y, and Z, then it makes sense.
So this guy sends the GPU back from the cloud. Feed directly from S3 to FFmpeg to HTTP has to be downloaded.
So we download to preferably ephemeral drives, local on EC2 instances, so we can have that disk speed, multi-part download, and then get it off there as soon as possible, so it becomes a swap disk. For the file transferring, depends on your volume, right, and what your concurrency is trying to do and how you can do that. So we'll also do things like we'll bring down the file so it's ready in queue before we actually go and transcode it, so we can keep our transcoding at a level that we want, but we have things staging, because that is a big issue. Now, inner transfers generally go faster, but it's still an issue. So we've looked at some other weird alternative things. If we're working like EBS, we've also done a bunch of tests on that and seen how that compared versus working with ephemeral, and then also like doing the flip on EBS to take it to S3 after the fact. So there's some interesting things you can go do, but it really depends on what's your time to market, or like what's your time to release, and your processing and the scale of your storage.
Yeah, because one of the things I'm considering is so far the scalability is still, if you got one file to encode, really the machine is not very fast.
Right.
Considering the slice and dice approach where you try and scope all your segments in parallel, what I'm wondering is sort of the I/O cost of doing that and combining or splicing.
Yeah, it's a cool concept. I think there's some. There's some things that you could probably do to help in that regard. Like S3 can do the byte range requests, get you down those chunks, and start doing those, especially if you're doing like a fragmented MPEG approach. So that in theory could work, and then you could just do a straight stream right from like a S3FS adapter that might work well if they perform okay. That's kind of the challenge. Ultimately the question was around like, hey, you have a disk I/O issue when you're working with cloud, and that means working with these big files and try to pull them in and push them around actually can be a bottleneck. And how can you try to be creative in distributing that, since we're not talking about generally using distributed encoding. So there's things that you can try to do by pulling certain chunks of files and splitting those up, but it's going to be an uphill challenge a little bit. It's not to say it's not doable. Happy to talk with you, brainstorm about it after.
Okay, I'm sure David will sit up here and answer questions. I'm going to have to run, but wanted to let you guys go for lunch. And anybody who has questions, just come on up and you can ask them directly.
Thanks, everyone.